Good day. Today we will be starting with trigonometry. Roughly stated, trigonometry means triangle measurement. And for the first part of this chapter, we'll be dealing with trigonometric ratios defined on a right triangle. In this case, we want to consider any two similar triangles. We know that if two triangles are similar, the corresponding angles are congruent and the corresponding sides are proportional. So if triangle ABC is similar to triangle XYZ, then angle A should be congruent to X, B should be congruent to Y, and C should be congruent to Z. And the ratio of the sides, corresponding sides, should be proportional, which means A is to X equals C is to Z equals B is to Y. Or A over C is the same as X over Z. A over B is the same as X over Y. And B over C is the same as Y over Z. So no matter how big the triangle is, the new triangle, for example, LMN, if triangle LMN is similar to triangle ABC or triangle XYZ, the ratio of the sides, let's say L, M, and N, L over N should be same as X over Z, should be the same as A over C. Okay? So, we will define the trigonometric ratios in the following manner. Okay, when we say the trigonometric ratios of an angle of a triangle, we of a right triangle, we are meaning um, an acute angle. Okay, so we can just choose which among between the two acute angles we will be dealing with. Is it angle A or angle B? In this case, we are dealing with angle A, and let's say angle A is theta here, theta. Okay, in relation to this angle theta, and this is a right triangle, this side here we know to be the hypotenuse. That's the opposite side of the right angle. And B here is the adjacent side. Okay, adjacent side to this reference angle here, theta. Okay, and then A here will be the opposite side. Okay, opposite side. Again, in terms of theta or angle A, side B here, the base of the triangle, right triangle, is the adjacent side. And side A here is the opposite side. And of course, we know that this is the hypotenuse. Now, define the trigonometric ratios as the following. Sine theta, abbreviated as sin theta, is actually the ratio A over C. That's A over C. That's opposite over the hypotenuse. Okay, that's the hypotenuse. And then cosine, abbreviated as COS theta, is the adjacent over the hypotenuse. Okay, adjacent over the hypotenuse. And tangent theta is abbreviated as tan theta, is actually the ratio A over B, or that's opposite over the adjacent side. Now, these are the basic definitions. Sine theta is opposite over hypotenuse, that's A over C. Cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. These three other functions here are the reciprocals of the ones above. So if you will notice, here, uh, sine and cosecant, okay, are reciprocals. Okay, so if they are reciprocals, that means their product is equal to 1. So A over C times C over A is equal to 1, which means sine theta times cosecant theta is actually 1. And notice also that cosine here is reciprocal to the secant. Okay? So we pronounce this one here secant as short I, okay? And then K and then A and secant is not secant, okay? So cosine and secant are reciprocals and tangent and cotangent are reciprocals. So, for example, we want to get the trigonometric ratios defined using that angle B. Okay? That angle B there. So, let's try. This is still the right angle. This is B, this is A, and this is C. Okay, if this is my reference angle, let's say that is beta here, I will define sine beta, okay, as opposite over hypotenuse. That's what? B over C. Opposite over hypotenuse. That's opposite over hypotenuse. Cosine beta. What will be cosine beta? This will now be the adjacent side. That will be adjacent over the hypotenuse. And the tangent beta is opposite over adjacent. Okay? Opposite over adjacent. And you can define the cotangent, secant, and cosecant. Remember, if you're using angle B here or the beta there as a reference, then A here becomes the adjacent side and B is the opposite side. Of course, this will always be the hypotenuse. So, for now, you need to memorize these ratios. Okay? So, when we talk about sine of an angle, acute angle, that is the acute angle of a triangle, right triangle. It's always the opposite side over the hypotenuse. And cosine will always be the adjacent side to that angle over the hypotenuse. And the tangent will be the ratio of opposite over adjacent. Some students would have an acronym for that, and they will say what? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Or that is SOHCAHTOA. SOHCAHTOA. So it should not be difficult for you to memorize the trigonometric ratios of an acute angle of a right triangle by just having this. So, ka, towa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, uh, I will remind you that in the work, in our work on trigo, sine theta here is not equal to, okay, sine theta. Or the capital S is not the same as a small s. Here we're dealing with all values of sine, so we will use this small s. If we look for this, then these are the principal values only, and we will not talk about this right now. So just be mindful that you will not write tangent theta as capital T, cosine as capital C, or sine as capital S, or this is capital C also, capital S. No, you don't. Okay? We will be using all small letters. Okay. How do we apply this trigonometric ratio definitions? Let's say, for example, here we have a right triangle. Right triangle, the hypotenuse of a right triangle is 10. Okay, so we have a right triangle, you draw, there's a 10, and then one of its legs is 8. So one of its legs is 8. Okay, and centimeters, we are supposed to find the trigonometric ratios of the angles opposite the 8 centimeter leg. Okay, opposite the 8 centimeter leg will be this. Of course, this is a right triangle and you're given the hypotenuse and one of the legs, you should be able to get the remaining side. So we are not given the remaining side. Instead, you're asked to solve. Okay, so you know that the Pythagorean Theorem will let you have this equation. A squared plus 8 squared equals 10 squared. And solving for this side here, you will get 6. Okay, we get the in your earlier work of quadratic equations, solving this by extracting roots would have given you a equals plus or minus 6. Okay, but we already want to get the positive because we are dealing with measurements here. That's why we disregard the negative. Okay, so what do we have here now? We have now the value of A, which is 6, the value of B, which is 8, and then the hypotenuse is 10. So with this reference angle here, we can now define the sine of theta. This is opposite side to theta, that's 8 over the hypotenuse. Okay, and then the cosine theta is adjacent side, that's 6 over 10. Okay, and then the tangent theta is opposite over adjacent, or that's 8 over 5. And then the reciprocals are here on the right side. Notice that we have a triangle similar to this triangle here as given by this primitive form of the Pythagorean triple. Okay, so we have a smaller triangle which is actually that's a 4 here, that's a 3, and that's a 5. And we know that these two triangles, triangle 1 and triangle 2, are similar because their ratios are the same. That's 8 over 10 is the same as 4 over 5. And 6 over 10 is the same as 3 over 5. And 8 over 6 the same as 4 over 3. So no matter if you have another right triangle similar to this, if you multiply this primitive form of the Pythagorean triple by 3, we will have, okay, this becomes 15, this becomes a 12, and this becomes a 9. And the ratio is still the same. 12 over 15 will still give us 4 over 5. Okay, 9 over 15 will still give us 3 over 5. And 12 over 9 will still give us 4 over 3. So that's what we mean, that if you have the trigonometric ratios of one triangle, right triangle, and you have other right triangles similar to it, then you will have the same trigonometric ratios. Okay? So now, you know more or less uh, the trigonometric ratios already. Okay, so let's try to uh, move on. Here, if we want to find the values of the six trigonometric ratios of the angle theta in this triangle, that should not be difficult already because this is the reference angle here, and this is the adjacent to that reference angle. This is the opposite to this reference angle, and this is the hypotenuse. So, similar to the example, what is now sine theta? Okay, we can now say sine theta is opposite of theta. That's 3 over 5. Okay, and what about cosine theta? Cosine theta is adjacent over hypotenuse, 4 over 5. And then tangent theta here will give me what? 3 over 4. Now you can get the reciprocal function. This is the reciprocal of sine is cosecant theta. And you just invert it, 5 over 3. And the reciprocal of cosine is secant theta. You will get here 5 over 4. And then cotangent here is the reciprocal of tangent, and that is 4 over 3. Notice that the values of sine and cosine will never be greater than 1. Okay? So this is 3 over 5 is less than 1. 4 over 5 is less than 1. But the reciprocals are different. Okay? So you can do the same for number 2. And for number 3, you need to get the hypotenuse. So if you recognize that 8, 15 is are the two parts of a primitive Pythagorean triple, the next one here should be what? 17. Okay? Or you can use the Pythagorean theorem. What's the Pythagorean theorem? C squared equals A squared plus b squared. And a here, let's say, is 8. So that's a 64 plus b is 15. That's 15 is 225. And you will get here 289. Okay. For this equation, c squared equals 289. Remember, this is a quadratic equation. And you solve it through extracting roots. You will get c equals plus or minus square root of 289. Or this is plus or minus 17. But we will get only the positive one. So it's 17. So you can now get the trigonometric ratios of this angle here. Okay? Now, for this number 5, number 6, they are in terms of letters. So sine of theta here will be opposite, which is P over R. Cosine will be adjacent over hypotenuse, Q over R. Tangent will be P over Q. Okay? Okay, that's all for this video.